Hi Lakers, this video is to introduce how we can use solids that we've been working with in the last week or so to create a composite solid. So what we're going to be utilizing is all of these volume formulas, and then we will build these 4 composites. After we go through these 4 problems, if you would like more practice, go to the next page. And when you are done with the 4 problems that I am demonstrating in my notebook, I want you to upload your notebook. Again, if you want more practice, it's optional. Otherwise, just focus on the 4 problems that we've done together. So let's look at the first one. This first one has 2 prisms. So we're using prisms in this composite. And the first thing I want to show you are the dimensions of the prism on the right. Notice we have a 5 right there. And then we also have a 7.5. And then we also have a 6. Those are the 3 dimensions of this prism over here. I'll call it prism number 2. Prism on the left, prism number 1. Now let's talk about their dimensions. Notice the height of this prism includes 4 and 5. And so that height is 9. Then we have a horizontal distance right here or right here. And that is the difference between 9.5 and 6. And so that distance is 3.5. Then the last thing that we need is this length right here. And that's the same as 7.5. So we have everything that we need for this composite. I'm going to rearrange my screen and show you my notebook. If you are keeping a table of contents, this will be our last lesson of Unit 4 and last lesson of first semester. Woohoo! You will be seeing this lesson on the 20th. You can see on the computer that I'm making it on the 19th. So let's talk about this first prism and find the volume. So remember those dimensions were 9 by 3.5 by 7.5. And just multiply all those together. And we get 236.25 units cubed. And then prism 2, those dimensions were 6 by 5 by 7.5. And we get 225 units cubed. So in total, this total composite has a volume of 461.25 cubic units. Now this second composite uses a cone and a cylinder. So let's first talk about the cone. We need the area of the base times the height, and then times a third, because the volume of a cylinder is 3 times the volume of a cone. So pi times the radius squared times the height. And in this case, the radius, if we look at this length, this is our diameter. And so that means our radius is 2.6 feet. And then the height of the cone, be careful. Notice the height of the whole object is 19. And if the height of the cylinder is 11, that means the height of the cone is 8. So now let's find that volume. 1/3 pi times 2.6 squared times 8. And we get about 56.63 feet cubed. And then let's look at the cylinder. Cylinder volume is just pi r squared times the height. Area of the base times their height. The radius is the same, but the height is different. The height of the cylinder is 11. The volume is pi times 2.6 squared times that 11. And we get about 233.61 feet cubed. So that means the total, when we add both of these volumes together, we get about 290.24 feet cubed, depending on where you round it. Slide that up. Now, excuse me, let's take a look at two prisms. Both of these objects are prisms. We've got a triangular prism. Notice the base of the triangle. So here we have a triangle prism. Find the area of the base, which is 1/2 base times height. The lowercase b, the base of that triangle, is the same as 45. And the height of the triangle is 18. But the height of the prism the height of the prism is the distance between the two bases. And notice the two bases are separated by a distance of 17 meters. So the capital H is 17. So to find the total volume of this triangular prism, we'll take 1/2 base times height times the height of that prism. And we get 6,885 meters cubed. Then looking at the rectangular prism, let's look at their 3 dimensions. We already have 17 indicated, and then we also have 45 indicated. The last thing to consider would be the height, right here, of 20. So the volume is a 20 by 45 by 17 meters. And we get 15,300 meters cubed. When we get the total, we see 22,185 meters cubed. It's a large volume. Now this last one I want you to envision this prism. Notice that it's closed. It's a, think about it as a 6 by 6 by 6. And notice at the top that we've got a circle. If we removed this, now we have a hole. So imagine taking that cylinder out, and we need to find the volume of what is left in this prism. So we need the volume of the cylinder and the volume of the prism. Having trouble with spelling prism today, my apologies. So with the cylinder, that's pi r squared times our height. So let's find our dimensions. Notice we are given the diameter. And so that means the radius of the cylinder is 2. The height of the cylinder, remember, is the same as the height of the prism. So the volume is pi times our radius squared times our height. And we get 24 pi. But now the prism, we just need the length times width times height. And we get 216. So that means our total is about 291, excuse me, 0.4, and our units are centimeters cubed. Thank you for watching these 4 problems. I will make sure to put an image of my notebook with these 4 problems so you can see them in the PDF. And then I also encourage you to go and look at the additional problems. Think about a hemisphere and a section taken out. Or this super challenge, finding the volume of a spherical shell that has an inner diameter and an outer diameter. Think like a piece of chocolate where you had maybe a cherry filling or a coconut filling or cream, nutty filling, whatever flavor you like, inside the shell. And we want to know just the volume of the chocolate. Think about that. It's a delicious super challenge. Either way, I will make sure that you can see solutions of these 5 problems, and I hope you are having a good day. Please join me in the Google Meet if you have any questions.